welcome to our third webinar about mastering film-forming amines. And today we're going to talk about the topic of continuous dosing under cycling operation. So again, let's start with a short recap from the last two webinars. And then I will give you some information about application guidelines with possible injection points, some recommendation for the dosing, and also some restrictions and challenges during the use of film-forming amines. And I will close this with some case studies of a combined cycle plant and a biomass plant. So to see some references and applications which we done in the past. So let's start with the first thing. So in the webinar number one, I've talked about the basics and guidelines, and the most important thing is that you should be aware about the IAPS TGDs on the application of film-forming substances in fossil, combined cycle, or biomass power plants, or the TGD about the industrial steam generators. Here's the website where you can find the TGDs. And the important thing to know is the terminology which is given in these TGDs, which is the film-forming amines, FFAs, are only the active substances, which are commonly named by ODA for octadethylamine, OLVA for oleoyl propylene diamine, and OLA. And then we have the film-forming amine products, which are the commercially available products, which do contain one or more of the FFAs and in some cases, additional products like alkalizing amines or something else. And then we have the film-forming products. They are commercially available products without FFA, which cause filming inside the system as well. And the generic term, which is film-forming substances, which covers all of the three different product types. And as always, it's critical to know the full composition of the product you are using, whether it's an FFAP or an FFP, to understand the effects in the system and to do an individual risk assessment for your plant. In the second webinar, we heard about the analysis procedures. So in the TGDs, there are two methodologies included. One is the extraction method with methyl orange. The other one is the xanthene dye reaction. From both, there are several information given inside the TGD. What we do not see is any recommendation on the concentrations of the product. So this is related to the manufacturer guidelines. And three different procedures are available. So we have the field test, which is a fast analysis, mostly done by grab sampling. And there's no additional photometer necessary to get information about the concentration in the system. But the sample needs to be analyzed quickly because there is nothing inside which allows the sample solution to be stored. So we get a filming of the sample bottle as well. So you need to follow the rules of sample taking, and then it will work very well. Then we have the laboratory procedures, which have a very high accuracy, a very low detection limit. And if you add the buffer solution, it's also possible to do a transport or storage of the sample taken from the system. But you need a specific laboratory equipment, and also you need to have some practice in doing those analytics to get reliable results. And the first thing is the online monitoring, which provides a continuous measurement of the FFA in the system with a very high accuracy. But of course, there are some investment costs related to the purchasing the system and the chemicals which are necessary. What is very important is that analysis is really, really important to get the exact values, and for that you need to know the composition of the used FFAP, because there are some difference between ODA and OLVA, for instance, when you use the methods. And so you need to know which product you're using, which FFA is inside, and only a measurement only of the pH when you're using FFAP with an alkalizing compound in it is not accurate enough to have a safe application, especially when you're doing a continuous dosing of FFAs in the system. So starting with the topic of today, I would like to give you some information why power plants, for instance, or also industrial plants consider the use of film-forming amines. So in most cases, it is due to some cycling operation because of an increasing of flexible power production. So you never know exactly when to start or when you will stop again. And on the same time, you will need to have a high availability. So you need fast startup times, and you need to protect the system in the offline period, whether they are 2 days or 2 weeks. And also you need to make sure that you really quick achieve the limits of the steam quality, especially to run the turbine. And in some cases, the plants need to start up very quickly without having the right quality for running the turbine without problems. So that's why there is a need of additional protection to the system. Also, load changes have an influence on especially in the phase transition zone at low or part load of the power plant. So you have fluctuating conditions. The area and especially the last steam blades can get wet and dry. And so the condensing point is changing, and this can cause deposits on the steam turbine. And also you can have an increased droplet impact, especially on the last turbine blades, which can cause erosion on those blades. And for those with the erosion and maybe some pitting corrosion from the offline, you can get cracks, which can be starting points for stress corrosion tracking. And also you have especially after a longer outage, you can have an increased corrosion product transport. So you get all the related issues with clogging filters and getting a lot of particles in the system. So in generally, we start to feed the FFA in the feed water tank, because here you have a good mixing within the feed water, and you can easily control your dosage by measuring the concentration in the feed water tank. Second option is the dosage into the condensate lines. The benefit is that you will shortly after starting the dosage, you will protect your preheaters. So if this is a point to look at in terms of corrosion, then it's always recommended to inject in the condensate lines. There might be a need for high pressure dosing equipment when you dose in this area, but you need to see the details of the plant, where is the best way to inject, and also what is the scope of the application. There is a specific, if you have an air-cooled condenser, for instance, then it might be useful to have a additional or the feeding right in front of the air-cooled condenser, because this is the equipment with the highest surface, mostly made of carbon steel. So if you get problems with offline corrosion, then it will be in this area. And here you can get a quick protection of the condenser surfaces if you inject right in front of the condenser, and maybe also have a positive effect on FFAs in this area, because due to the injection of film-forming amines, the water droplets, the diameter of the water droplets is decreasing, and by this the effect of drop impinement corrosion is reduced, so that we get less material losses, especially in the two-phase areas in the entrance of the air-cooled condenser. So in generally, the cycling operation is characterized by operation times and standstill periods. Whether these standstills are unpredictable, because they can be on a short notice, and then you never know how long will this standstill be. Is it a small one, or will it take longer? So it's really difficult to apply the standard preservation procedures like drying of the system, or filling the system and capping it with nitrogen. So, and especially if you have a daily starts and stops, then it's really, really hard to find the optimum application. So in this time, the film-forming amines can be a very good solution. They will be dosed at a very low concentration. This concentration is depending, of course, on the used product, but also on the operational time in regard to the standstill time. So if you have more operation and less standstill, so you can go with a lower concentration. If you are facing a lot of standstill with very short application, very short operation cycles, then it might be useful to have a higher concentration of filming amines as a residual in the system. This is the concentration after you have the complete filming of the system, so the residual, which we can measure with the analysis procedure introduced in the last webinar. Of course, if you have a continuous dosing, you need to monitor your concentration very frequently, that you make sure also in load changes and low load operations that you do not exceed the concentration limits to create any problems in the system. Of course, it would be much recommended to use an online monitoring system to be safe at all states, or to perform a regular lab analysis twice or 3 times a day to make sure that the concentration is in the right target. When you're starting adding FFA, you will see that you might have some changes in your water chemical values, especially when we look at the conductivity after cation exchange or other values, because we have an implementation phase where there are some changes, especially when there are some impurities settled down on the surface. They will be removed and captured with the FFA, and so we will see an increase. But after a while, maybe 2 or 4 weeks, this depends on the system, on the concentration, on the operational parameters, we will see again stable values, and a new baseline may be forecast because of the organic matter of the product and the created CO2. This might have an effect on the conductivity of the cation exchanger. Yeah, of course, there are some restrictions. talked already about the case increase. It is an organic molecule, and it will start to decompose at temperature above 400 degrees Celsius. So it will form mainly volatile products. So it's CO2 and NH4 and other volatile products, which depends also on the used FFA, but also on the used film-forming amine products and the other byproducts which are in this mixture. In some cases, it is reported that it will come to a formation of low weight organic acids. So you need to check again what is the composition of the product, what is inside of this. If you use a blended product or a mixed product, what are the individual active substances and what risks are according to that. And if you have a creation of carbon dioxide, you will increase the case, especially in the conversion time during the first weeks. But after having a equilibrium formed and just keeping the residual very low, so it's possible to also stay within the limits of 0.2 microsiemens in the system. In some cases, it's a little bit higher, but this is, as said, depending on the product and depending on the concentration in the system. If possible, and maybe if it's installed, you can use a degassed conductivity, which removes the volatile gases from the sample, and then you can see, again, very low conductivity values. And this will help also to avoid the influence of the CO2, which is created by the decomposition. And you can easily detect any leakage from the condenser with this method. Another part is if you're having a condensate polishing plant in operation, in those mixed bed resins, the FFAs are accumulated in the filter vessel. So we saw some applications where they, especially after treatment with very high concentrations, that the top layer of the resin is floating up. And so this is due to the accumulation of the FFA in the resin bed, and then it comes because of density, it comes to like a floating effect, and because of the temperature and the saturation concentration, we see a white layering on top of the resin bed. But this can be solved by increasing the temperature in the condensate polisher. And also we did some research on that and see that especially when you do a warm regeneration or an additional treatment with caustic, that the capacity is not affected, and also the regeneration process can be done normally without having any influence on the capacity of the used resins. But as always, you should try this before applying FFA with your resin in place and the blend FFA to see if there's any negative effect, and to be aware of this before you start the application. So let's come to a few case studies. So the first one is a combined cycle unit located in western part of Germany. The system is consisting of 2 gas turbines, 2 HRSGs, and 1 steam turbine without a condensate polishing unit, and it's under flexible operation with very low operational cycles, and a very fast startup was required. So the initial situation was that even with a already existing preservation in place, there were some problems with high iron levels during the restart, especially in the intermediate pressure section. And then it comes to clogging of filters in the condensate, and they had to shut down the plant again during the restart to clean the filters and do the restart again. And we applied the dosing into the condensate line after the condensate pump using a high pressure dosing system. And we could measure the pH case and also degassed case online, and did a grab sampling for the FFA analytic. And we saw very good results, especially in the condenser area and in the last stages of the steam turbines. We had established a good layering, and also the iron concentration during the restart was reduced by 70%, so a very good effect for the plant, no clogging of filters anymore, and also they don't need to do an additional nitrogen injection in the boiler and or a drying for the system, especially the steam turbine and condenser, for corrosion protection. They just did using the FFA. And the other example is a biomass plant in Sweden, which is running only during the winter time and then only for peak load operation. So also here, very flexible operation with a lot of starts and stops. We injected the ODACON here from in the feed water system, and established a concentration around 0.3 ppm in the of FFA in the system. And also here we could see that the before the feed water tank was at a red surface, a lot of corrosion in the bottom, and also with increased pH there was no effect, especially also on FAC. And with the treatment we have the change from red to a gray magnetite layer, and the white spots you see on the top, these are very small water droplets, and after opening the vessel, and they disappeared very quickly during the annual revision. So the feed water tank was very clean and very well protected. And on the steam turbine, there were already some corrosion ongoing, especially FAC corrosion and also offline corrosion. Because of some boiler carryover, there were also some scale formation already. And after applying the FFA, we get shining surfaces and no signs of a further corrosion, and also deposits get less. So we had a very good effect on the overall plant situation with the continuous dosing at low concentrations. So now we are already on the end of the webinar, and would be happy to answer some questions if there are some. And yeah. So no questions so far. Okay. So if you need to know anything else, oh, there's one. There's a product question from Sarah Hassan. Yes, it is only a film-forming amine. So our product does only contain film-forming amines. So no alkalizing and no other non-volatile parts, just a volatile film-forming amine. David? Yeah, the concentration at the biomass plant was around 0.3. ppm residual in the system due to some changes in the load and some standstill. So we choose a little bit higher concentration. Yes, we saw some effect also on the turbine cleanness. As I showed you on the last slide, there were some deposits on the blading and also some corrosion spots due to carryover over the several years. And if you have a look on the last picture, you see less deposits. So this was a revision where they took out the steam turbine completely. And so we could see even the turbine manufacturer was very surprised by the cleanness of this turbine. Any hydrophobicity on the superheated steam? Honestly, I cannot tell you, David, because we were not taking part the revision, but we only could get some pictures. So I don't know. So Mark is asking about subcritical plant, which was in storage. So the time for preservation, the longest period we know was about 5 years. This was a nuclear plant after a major replacement of components. They did a preservation before the shutdown, and then the recommissioning was about 5 years later. We did some preservations here in Germany for some coal-fired units, which have been in a cold storage, and one of the plants was recommissioned after 3 years of offline of storage. So, but they were all drained. So the wet storage, I don't know. I don't know if I don't think there's any effect whether it's wet or dry stored, because when you store it wet, you always have some FFA in the water, and so this should not be a big issue. David was asking, testing for residual nitrogen. No. No testing for the nitrogen on the blade surface. All right. So thank you all for your questions and for your attention. So, oh, sorry. We can already spoil a little bit for the next one, which will be on the 4th of September. So, and we will have a webinar on the preservation, so which fits very well to the last questions. So we will talk a little bit about possible preservation strategies and also see some case studies from the already mentioned plants where we did the preservation before the storage. So thanks everyone for your attention and following, and hope to see you next time again in about 4 weeks. Same time, Wednesday at 1. And yeah, have a good day, have a good night, and See you. Bye-bye.